Hi all. So in today's class, we will start a new subject, that is linear control system. So this is in this semester EET 302. So in today's class, we will be seeing what is actually linear control system, what is the difference between open loop, closed loop system, and then automated control system. Okay, let's see. So here we can see that I have listed some topics which you have already learned in signal science system in 5th semester. So block diagram representation. So how to form a block diagram, then how to reduce it, all these things you have studied. Then how to form the signal flow graph and Mason's gain formula, how we can form the transfer function, that also you have seen. Transfer function, how we are writing. Then type and order of the system, and then the characteristic equation for first order and second order you have studied. Then determining the time domain and frequency domain. So time domain that is changing with respect to time, and frequency domain that S is equal to j omega. I think you are remembering. And then about the stability of the system. So bounded input should give bounded output. Then Routh-Hurwitz criteria like number of right hand poles, left hand poles. So these things you have studied in module 3. So if you want these areas to be refreshed again, because you need these basics to study this linear control system in this semester. So if you want me to make a video, do comment in the video, then I can make a short video, like in 1 or 2 hours, I can deliver all these topics in my videos if you want to. Okay, so now let's start module 1. So if you check the syllabus, you can see that module 1 has 4 parts. Like if you see 1.1, 1.2, 1.3, 1.4, it is divided into 4 parts, and you know that there will be 14 marks. Right? No, sorry, 20 marks. Total 20 marks, and 40 marks from B part and 6 marks from A part, right? B part and A part. So that is module 1. Okay, now let's start this. So today I will be dealing with terminology and basic structure of open loop and closed loop control system, as well as automatic control system, the block diagram representation. Some examples, practical examples. Okay, so first of all, let's see what is a control system. So control system is actually a device, actually a system of devices that manages, commands, direct, or regulate the behavior of other devices or system to achieve a desired result. So we have a system. So it is actually controlling the system so that we get a desired output. So for example, this is the system, and we are giving an input and we have an output. So we are providing some control to a system. For example, if you take an air conditioner, we are controlling it by using some other device so that we get the output. So that is what we call a control system. So okay, we'll see. So practically every aspect of our day-to-day life is affected more or less by some type of control system. So best example I told you, air conditioner. So how we increase or reduce the temperature, all these things. So examples of control system in your day-to-day life include air conditioner, of course, then refrigerator, the fridge that we take, air conditioner, a bathroom toilet tank, automatic iron, and many processes within a car. So everybody will be driving a car, right? So you can control the cruise control is there, right? So that is a very good example of control system. The speed we can control. Okay, so this is the best example of control system. Okay, so what are the features of control system? The main features of control system is that there should be a clear mathematical relation. That's what I told you. So this is the input and this is the control system and this is the output, right? So there should be a mathematical relationship between input and output. When the relationship between input and output can be represented by linear proportionality, the system is called linear. So the relationship between output and input should be linear. then we say it's a linear control system. So in this particular subject, this particular subject's name itself is linear control system. So most of the things we will be studying linear things. When the relationship between input and output cannot be represented by linear proportionality, rather the input and output are related by some non-linear relationship, the system is referred to as non-linear control system. So you can hear input time interval is there, then output. So this is maybe bread toasting or something is being done. So this is an open loop linear control system. And before getting in more detailed into control system, there are certain terminologies or requirements of a good control system. So they should possess these features. So these features, some of these features you have studied in your measurements also. A machine should possess these things. So first one is accuracy. A control system should be accurate. First point is accuracy. So it is the measurement tolerance of the instrument. You can take any instrument and defines the limit of errors made when the instrument is used in normal operation. So what are the errors happening? So it should be error free. That is, it should be more close to the actual value. The measured value should be, that is the desired output. The output that we get should be more close to the desired output. So there should not be much difference between the actual output and the desired output. Okay. So we normally use the error detector, such things. Then sensitivity. The parameters of a control system are always changing with change in surrounding conditions. So it should, so a control system should be insensitive to the external factors. So maybe a noise is coming, it should be insensitive. It should be depending only, it should be sensitive only to the input signal. So however we are, whatever input we are giving, we should get the output. Okay. Then noise is unwanted signal. An undesired input signal is known as noise. A good control system should be able to reduce the noise effect for better performance. And stability. So moving ahead, we will be studying a lot about stability. And last semester also you have studied about stability by using Routh-Hurwitz criteria. So if you have a transfer function, then depending upon the location of the poles and zeros, to be more precise, depending upon the location of the poles, whether it is on the right hand side of the real axis or left hand side of the real axis, or if they are on the imaginary axis, we say the system is stable or unstable. So stability is very important. So in this semester also we are studying these things, next module and all. So it is an important characteristic of the control system. For the bounded input signal, the output should also be bounded. So bounded means not going to infinity. So it is coming to a stable value. Okay. So if the input is bounded, then output also should be bounded. And if the input is 0, then output must be 0. So that's when we say it is a stable system. So if it is going to infinity, then we cannot say it is stable. It is unstable system. And bandwidth. So bandwidth also, you might be, you have studied different types of filters, low pass filters, high pass filters, band pass filters. So based on the frequency, we say an operating frequency range decides the bandwidth of the control system. Bandwidth should be as large as possible for the frequency response of a good control. So we need a higher bandwidth. And speed, it is the time taken to achieve the output. We give the input and there will be some time to get the output. So we have studied in power electronics, delay time, rise time. So the speed will depend on all these things. A good control system possesses high speed. So going ahead, you will study all these things in detail. This is just the introductory session. And oscillation. So you going ahead also, you will study settling time, peak overshoot, all these things. A small number of oscillation or constant oscillation of output tends to indicate the system to be stable. Oscillation should be very less. So that was the introductory part. Now coming more into the subject, you can expect a question from here, maybe a 3-mark question in your university exam. What are the two types of control system? First one is open loop control system and second one is closed loop control system. Very, very important. First of all, let's see about the open loop control system. So open loop control system, a control system in which the control action is totally independent of the output. So we give one input, so whatever we are giving, that we are getting an output. So it is independent of the output. It's called open loop system. So a manual control system is actually an open loop. So So you have two types of control system, open loop and closed loop. And similarly, you have manual and automatic also. Manual into automatic. So control system can be a manual type or automatic. Manual means a human being should go and give the command. Automatic means there is no need of any human intervention. It can happen automatically. Example also I will give you. So example of an open loop system. So you should be very careful about these things. So before going to that, you see a desired process response. So we are giving to the controller. So controller is out, controller output is coming. So that controller output is given to the process. So the process can be cooling, refrigerator means cooling, or heater means heating. So the process can be anything. So the controller output is given to the process, and we are getting the process output. So normally what we say, so if you have a input, so input is represented by R of S, that is reference input, and output will be C of S, that is the desired output. Okay, and this is the control system, open loop control system. Okay, so example is, first one is electric hand dryer. So if you go to hotels, you can see electric hand. If you keep the hand there, then your hand will be dry. Hot air comes out as long as you keep your hand under the machine, irrespective of how much your hand is dry. So even if your hand is dry, or even if it is wet, if you keep the hand, the sensor will be activated, and your hand will be dry. You will get hot air, right? So first is select. Then automatic washing machine. This machine, according to the preset time, irrespective of washing is complete or not. So if you are setting 14 minutes or 15 minutes, you have different modes, right? Even 3-hour mode is there. So even if the washing is finished, that 3 hours will be completed because it is open loop, because output has nothing to do with this function. Whatever the system is doing, output has nothing to do. What is our output? The cloth should be dried. So even if the cloth is dried, still the machine will work for the set time. That's why we say it's a open loop system. So this is another example. The dryer. The dryer stops working even if the desired output is not obtained. So we are drying the clothes in the washing machine, you see. So we have set a time. So maybe 3 minutes or 5 minutes. So after 5 minutes, the dryer will stop working. And there can be disturbance also. So the cloth is not actually dried, but it has stopped working. This shows that system has no feedback. The output is nothing to do with the output. Here, cloth dryer is the example of open loop system, and timer is the controller of the system. But still, it's not a closed loop control. It's a open loop control. Now let's see some advantages and disadvantages of open loop control system. This you can also expect a question from here. University exam can ask this question. First one is simple in construction and design. It's economical, easy to maintain, generally stable, convenient to use as output is difficult to measure. Then disadvantage is they cannot be that much accurate because you see there is no control, right? It's the open loop control. They are unreliable. Any change in output cannot be corrected automatically. So if suppose we give the input and we are not getting the desired output, that cannot be corrected automatically. We should do something else. So that's the case of open loop system. Then closed loop control system. Very important. The control systems in which the output has an effect on the input signal. So output has an effect on the input signal. Then we call it's a closed loop system. That the input quantity will adjust itself. So output will have some effect on the input. So output will be fed back. If there is some error happening, then output will be fed back on the output generator. So an open loop system can be converted to closed loop if you're giving the feedback. So you study feedback in the next session, 1.2, positive and negative feedback. So you see the input is there is amplified and given to the controller. So according to the requirement of the controller, so maybe the controller wants a 5-volt input, then it should be amplified, right? So controller, and then the process is happening, and then the controller output is the output we are getting. So input. So if you talks in terms of Laplace R of S, then C of S. Don't worry, we will study. So reference into. So some form is being fed back. So then there is some difference. The output and input is having some difference, and that is the error E of S. That is the representation in Laplace. So if in the time domain it is E of t, then in Laplace it will be E of S. So if this is R of t, then in Laplace it will be R of S. So if it is C of t in time domain, then it will be C of S in Laplace domain. That's it. You'll study in detail if you haven't studied this in previous semester. Time domain, and this is Laplace domain, S domain, you say. S domain. So this is being fed back and error B is being again amplified, and then so this is a cyclic process and this happens automatically. So the output, any change in the output can be corrected. Any undesirable change in output can be corrected. That's it. So one very good example, this is actually an automated control system. So your syllabus specifies about automated control system, block diagram. So this can be drawn. So this is an air conditioner. This is an example of closed loop system. The air conditioner regulates the temperature by comparing it with the surrounding temperature. So regulation is happening. The thermostat will know. The comparison of temperature is done with the help of thermostat. When the AC provides the error signal, which is the difference between the surrounding temperature and room temperature, the thermostat turns on or off the compressor. So the compressor will be on and off based on the surrounding temperature. So we can leisurely sleep. We need not switch it off or switch it on. It happens automatically. So room temperature is there. It is being desired temperature is there. So error is there. So if it is not reaching the desired temperature, that will be an error and that will be fed back, and this cyclic process will happen. Feedback is being given. Now let's see some advantages and disadvantages of closed loop system. Closed loop system are more accurate in the presence of non-linearity. So basically we are studying linear system, but we can say the more accurate. Highly accurate, as any error arising is corrected due to feedback. Bandwidth is very large. So a good system, a stable system should have a more bandwidth, right? Good control system, facilitate automation. Yes, automated control system. You have just seen the example, air conditioner. Then sensitivity of the system may be small to make the system more stable. It is less sensitive to other things. So we give the input. So it is more focused on giving the output, desired output to be more precise. This system is less affected by noise. Disadvantage is the control system becomes very complex, they're more costlier, complicated to design, require more maintenance. Feedback leads to an oscillatory response. That is very important. So you'll study in detail about oscillation and all. Overall gain is reduced due to presence of feedback. So you will understand that in terms of the control system. Like while writing the transfer function, you'll understand how the gain is being reduced. So because depending upon positive and negative, depending upon what type of feedback we are providing, the gain will be either increasing or decreasing with study. Stability is a major problem and more care is needed to design a stable closed loop system. Stability, more care is being required. So now I have summed up whatever we have studied today, the difference between open loop and closed loop system. So open loop means no feedback. The feedback element is present. Error detector is not present. Sure, here error detector is always present. It is a stable one. It may become unstable, easy to construct, complicated construction. It is uneconomical. It is costly. Having a small bandwidth, having a larger bandwidth, all these things we have studied just now. The feedback element is absent. The feedback element is always present. Having a small bandwidth, larger bandwidth, less maintenance, more maintenance. Example, hand dryer, tea maker, open loop system, servo voltage stabilizer, then perspiration, so that controlling heating and all, they're all because that is thermistor dependent, right? So that is closed loop system. So I hope what is the difference between open loop into closed loop, and then examples, block diagram representation, then automated system is clear for you. So next class, you will be studying what is a transfer function, then positive and negative feedback, and many more things. 1.2 maximum I'll try to cover. Thank you.